Hello everyone, welcome back to the map of mathematics. In this video we are going to solve this nice algebra problem, and here we have 49 to the power of n plus 119 to the power of n is equals to 289 to the power of n, and we will solve this problem for the real values of n. So the very first thing we are going to do is, here first I can divide each side by 49 to the power of n, so that you get the output in the form of 49 to the power of n. This is also divided by 49 to the power of n, and this is also divided by 49 to the power of n. And here you see that these two are similar terms, so that it is gone, and here you get only 1 plus, here you see that you have 119 over 49, and here I can apply the nice exponential law. And you know about this law, if we have a to the power of n over b to the power of n, it is equals to a over b to the whole power n. We will use here this nice law, so that according to this law I can write the above equation as 119 over 49 whole power n. Here I can just combine these two exponents and I can write in this form. Similarly, in the right hand side we will again combine these two exponents, and we will write it as 289 over 49 to its whole power n. And after this step we will write this 119 as 1 plus, it is equals to 7 times of 17, because 119 is equals to 7 times of 17, and whole over you have 49, and 49 is equals to 7 times of 7, and its whole power n is equals to, here you have 289 over 49, and 289, the perfect square of 289 is 17 squared. 17 squared is equals to 289, and similarly the perfect square of 49 is 7 square and its whole power n. After this step we will make a little bit simplification here. So here you see that these 7 are gone, and we will get the output in the form of 1 plus 17 over 7 and its whole power n is equals to, here I can use an exponential law. In this exponential law we will make the exponent of 17 and 7 in combined form, so that you get 17 over 7 whole squared and its whole power n. After this step I can use another exponential law, and you know that about this law, if we have a to the power of m to the power of n, it is equals to a to the power of n and its whole power m is equals to a to the power of m times of n. So this exponential law tells us about, if you can interchange these two exponents, then it cannot be affect the answer of this question, so that you can or here we need to interchange these two exponents, so that after interchanging these two exponents we will get the output in the form of 1 plus 17 to the power of n is equals to, here you get 17 over 7 to the power of n and its whole squared. So after this step we will convert this exponential equation into the quadratic form, so that here I can take y is equals to 17 over 7 to the power of n. So after substituting y is equal to 17 over 7 to the power of n, you will get the output in the form of 1 plus y is equals to y square. So finally you get the equation in quadratic form, so that we will just solve here this nice quadratic equation, so that here you get, first I can rearrange this term and we move these two terms in the right hand side, and you get y squared minus y minus 1 is equals to 0. And now I can use here the nice exponential law, the quadratic formula, in order to solve this nice quadratic equation. And here we have a is equals to 1, b is equals to minus 1, and c is equals to 1. So now you put the values of a, b and c in the quadratic formula, and you know about the quadratic formula. We have y is equals to minus b plus minus b square minus 4 times of a and c square root and whole over 2 times of a. So now we put the values of a, b and c here, and you get here you have the value of b is minus 1, so this minus minus becomes plus 1, and plus minus, here you have b square, the value of b is minus 1, so minus 1 square is plus 1, minus 4 times of a is 1, and c is again 1, and its whole c, the value of c is minus 1, so it will becomes minus 1, and its whole square root and whole over 2. So now you can simplify the terms, and you get 1 plus minus, here you have minus minus plus, and 1 plus 4 is equals to 5 square root over 2. And now here we have two cases. The first case is we take y is equals to 1 plus square root 5 over 2, and the other case is we take y is equals to 1 minus square root 5 over 2. And now we back substitute the value of y in the start of the question. We will take y is equals to 17 over 7 to the power of n is equals to 1 plus square root 5 over 2, and similarly here you put 17 over 7 to the power of n, and it is equals to 1 minus square root 5 over 2. And in the left hand side you see that we have exponential function, and you know that exponential function always gives the positive value, and this expression gives the negative value. So it cannot be possible an exponential function is equals to negative value, so that we will reject this case, and we can just proceed here this case only. So in order to solve this case, you can take the log on both of the sides, so that here we get log of 17 over 7 to the power of n is equals to log of 1 plus square root 5 over 2. And now we can use the property of log, so that this exponent will move in the front of this log, and you get n times of log 17 over 7 is equals to log of 1 plus square root 5 over 2. And now you can use the calculator or logarithmic table in order to find the values of these logs. So after using the calculator, you will finally got the value of n is 0.5423, and this is our final answer of this question. And thank you so much for watching this video. Please subscribe to my channel for more exciting videos.